Greetings learners! This video is made for educational purposes, and we are here to present you what and how we've done our fourth experiment, which is about energy and momentum. The main objectives that the learners should achieve in this experiment are the following: define momentum and other concepts related, identify all the equations revolving in the experiment, and explain the lesson itself and applied all the learnings.
So in this experiment, there are two concepts being used, which are momentum and collision. The former is a vector quantity that depends on the direction of the object. It is also a concept that appears along with collision, symbolized by the capital P equals mv. Capital P stands for momentum, m stands for mass, and v for velocity. And the product itself should be expressed in kilogram by meter per second. On the other hand, the latter, collision, then refers to the contact of two bodies with exerted forces, simply colliding. There goes inelastic, elastic, and perfectly elastic collision. These two concepts are analyzed in such vehicles or sports. Now, let us proceed to the experiment proper.
Before we proceed to the experiment proper, here are the materials needed. 3 ball types with the examples lined up below. 3 surface type. Again, examples of such are given below. Other materials needed, as well as gram scale, tape measure or meter stick, and bouncing balls worksheet to be flashed at the next page. As the worksheet was seen on the screen, press the pause button and take screenshots of the table.
Data and results section then are comprised of the following: equations, explanation, answers, and documentation, one per case. This equation shall only be used once since the drop object is only dependent on the height where they dropped from, not the mass of the ball per se. Initial velocity will be 0 and time will be disregarded for the meantime, since the only given values are the vertical height and the gravity per se. In finding the starting velocity, which is the final velocity, the product of the acceleration or gravity, which is 9.8 meter per second squared, and vertical distance 1 meter, shall be doubled and then find its square root. And by that, the starting velocity of all cases shall have the same value, which is 4.43 meter per second. In finding the ending velocity, the same formula is still being used, but the final velocity value then will be 0, and the maximum height being taken note of shall then be used as a vertical distance, resulting to various values of answers. It is also evident that all the ending values being solved shall then be expressed negatively, knowing that initial velocity squared is transposed. Starting momentum does not necessarily mean the product of the object's mass and initial velocity. No. Experiment being conducted started by dropping the object at the given height, and that is when the ball started losing its momentum. Just like how the starting momentum was calculated, the ending momentum shall be solved too by multiplying the object's mass and velocity. What made this different is that the initial velocity then will be used instead of final, since initial velocity is the second value evident in the experiment wherein it bounced and reached the probable maximum height after reaching the low surface. Simply stating, the change of momentum is just the difference of both starting and ending momentum, with a sign disregarded since it was only the difference asked. And in order to determine how much is the momentum change all throughout the process, simply divide the change in the momentum with the starting momentum, then multiply to 100 in order to obtain the percentage of the lost momentum.
As of this case number 1.1, these are all data calculated. Table 1, data of the case included the following. Mass 0.0460 kilograms. Maximum height 0.880 meters. Collision type elastic. Table 2 data of the case included the following. Starting velocity 4.43 meters per second. Ending velocity negative 4.15 meters per second. Starting momentum 0.204 kg by meter per second. Ending momentum 0.091 kg by meter per second. Change in momentum present in the data is 0.113 kg by meter per second, which is 55.39% all throughout the equation. As of this case number 1.2, these are all data calculated. Table 1, data of the case included the following. Mass 0.0460 kilograms. Maximum height 0.250 meters. Collision type inelastic. Table 2 data of the case included the following. Starting velocity 4.43 meters per second. Ending velocity negative 2.21 meters per second. Starting momentum 0.204 kg by meter per second. Ending momentum 0.102 kg by meter per second. Change in momentum present in the data is 0.102 kg by meter per second, which is 50% all throughout the equation. As of this case number 1.3, these are all data calculated. Table 1, data of the case included the following. Mass 0.0460 kilograms. Maximum height 0.290 meters. Collision type inelastic. Table 2 data of the case included the following. Starting velocity 4.43 meters per second. Ending velocity negative 2.32 meters per second. Starting momentum 0.204 kg by meter per second. Ending momentum 0.109 kg by meter per second. Change in momentum present in the data is 0.095 kg by meter per second, which is 46.57% all throughout the equation.
As of this case number 2.1, these are all the data assessed. Table 1 data of the case included the following. 0.0027 kilograms of mass with a maximum height of 0.580 meters that results of an elastic collision type. The second table shows the following results. It has starting velocity of 4.43 meters per second and came up with an ending velocity of negative 3.37 meters per second. The starting momentum is 0.012 kg by meter per second. That finishes an ending momentum of 0.009 kg by meter per second. The change in momentum present in the data with a value of 0.003 kg by meter per second, which is 25% throughout the equation. And for the case number 2.2, these are all the data assessed. Table 1 data of the case included the following. 0.0027 kilograms of mass with a maximum height of 0.140 meters that results of an inelastic collision type. The second table shows the following results. It has starting velocity 4.43 4.43 meters per second and came up with an ending velocity of negative 1.66 meters per second. The starting momentum is 0.012 kilograms by meter per second that finishes an ending momentum of 0.004 kilogram by meters per second. The change in momentum present in the data with a value of 0.008 kilogram by the meters per second, which is 66.67% throughout the equation. And lastly, for the case number 2.3, these are all the data assessed. Table 1 data of the case included the following: 0.0027 kilograms of mass with a maximum height of 0.560 meters that results of an elastic collision type. The second table shows the following results. It has starting velocity of 4.43 meters per second and came up with an ending velocity of negative 3.31 meters per second. The starting momentum is 0.012 kilogram by meter per second that finishes an ending momentum of 0.009 kilogram by meter per second. The change in momentum present in the data with the value of 0.003 kilogram by meter per second, which is 25% throughout the equation.
As of this case number 3.1, these are all the data calculated. Table 1 data of the case included the following: mass 0.0060 kg, maximum height 0.740 meters, collision type elastic. Table 2 data of the case included the following: starting velocity 4.43 meter per second, ending velocity negative 3.81 meter per second, starting momentum 0.027 kg by meter per second, ending momentum 0.023 kg by meter per second. Change in momentum present in the data is 0.004 kg by meter per second, which is 85.19% all throughout the equation. As of this case number 3.2, these are all the data calculated. Table 1 data of the case included the following: mass 0.0060 kg, maximum height 0.130 meters, collision type inelastic. Table 2 data of the case included the following: starting velocity 4.43 meter per second, ending velocity negative 1.60 meter per second, starting momentum 0.027 kg by meter per second, ending momentum 0.09 kg by meter per second. Change in momentum present in the data is 0.018 kg by meter per second, which is 66.67% all throughout the equation. As of this case number 3.3, these are all the data calculated. Table 1 data of the case included the following: mass 0.0060 kg, maximum height 0.770 meters, collision type elastic. Table 2 data of the case included the following: starting velocity 4.43 meter per second, ending velocity negative 3.88 meter per second, starting momentum 0.027 kg by meter per second, ending momentum 0.023 kg by meter per second. Change in momentum present in the data is 0.04 kg by meter per second, which is 85.19% all throughout the equation.
perfectly elastic collision is pretty much inexistent. When the ball bounces up and down, the energy the ball possesses shall then be transferred elsewhere, probably the ground, or it turns to another type of energy, which is why the momentum is lost. If an object loses 50 units, for instance, another object will then gain the unit lost by the first object. Gaining and losing is a statement then, describing the momentum transfer process. Perfectly elastic collisions, as stated on one of the scientific accounts, hyperphysics, shall then be defined as a scenario wherein there is no energy lost in the case. Knowing that values won't change in the said type of collision, then it must mean that the momentum of such is being conserved all throughout, or as long as there is no movement of air intervening the case.
In playing the dodgeball, opt for the ball with the lowest momentum. And by that, our best choice in duping the dodgeball will be the ping pong ball. So, when the ball hits you or your teammates, the impact or damage will not be severe. The ideal ball for bowling then is the golf ball since it weighs the heaviest among the balls being tested. Bowling is more of a slip and slide game, and the ball shall be used would rather roll along the lane than bounce. And by bowling, in order to knock over the pins and attain a strike, a heavy ball is needed and a large value for momentum too among all the balls being examined. A good combination to dupe the basketball game shall be a bouncy ball and a tiled floor. Golf ball and ceramic tiles will coordinate well during the game since the court is preoccupied half by half with the players dribbling and passing the ball. Jackstone ball and a carpeted floor then fit the street hockey standards. We all know that hookers, their wooden sticks, are used in passing the conventional hockey puck and traveling in the rink. Having a bouncy ball won't be good in the game, with the trouble of hitting and passing the ball and getting the goal. Street hockey and the ideal court and ball are both rough on gameplay.
Deleuve Kenyle. In English, simplify means mid-air ball. Integrated in this game are principles of tennis and volleyball, plus the collision concept emphasized. To play the game, make sure to form two teams with 3 players each playing in the court. One team player shall first serve mid-air, passing over the net, and the opposing team player must toss the ball back in the opposite court. Winning basis is best of 3, garnering 11 points per round. Points shall be earned if the opponents of the team did not let the ball dribble or if ever the ball touched the court twice. Since the game has multiple rounds, reaching 3 teams, then also the chance to switch. The twist in the game is that they are able to get the ball to touch the floor once every turn and only 3 players per team are inside the court. Per se, ball is made of ether foam or synthetic leather so that the ball can reach the probable maximum height and easy to control when serving and receiving throughout the game. Plus, moderate impact whenever they hit the players. Hard court has a great impact on the ball, but not so much for players, which make the game an indoor enjoyment sometimes.
I never expected that this experiment in calculus-based physics would be really that easy, so my groupmates and I therefore conclude that
After the experiment, now I know that not all the ball has the same bounce height. It all depends on the type of the ball and the surface where it bounces.
I learned that the ball and the surface where it fell on may affect how high the bounce will be. Like dropping any ball on a carpet makes the bounce slower.
Collision does not only apply on the ball tested, but to people and vehicles too.
We may not always recognize it, but doing this laboratory, we have understand its concept and how it works.
what about you? What can you conclude? Share us.